Hello and welcome to my tutorial on how to name ionic compounds, polyatomic ions, and also molecules. So to start off here, we're gonna name some ionic compounds. So we have sodium and sulfide. Sulfide, yeah, you can look for it on the periodic table. It's not there, but when you're naming these in letters like this, it has an I at the end of the second letter, or kind of I, or something like that. So, to start us off, so we need to find sodium on the periodic table. So, as we might or may not know, sodium is Na. So, where's my Na? So, if you also look up here, I have these numbers at the top of the periodic table. Those are oxidation numbers. Oxidation numbers are very important when it comes to writing these down. So sodium is 1 plus. So sodium is right there. So put a little 1 plus right there. So, and then we have to find sulfide, which is sulfur right there. And its oxidation number is 2 minus. So, there are two ways to write these down. This isn't the complete way right here. This is not the complete way. So, I'm going to show you two methods to write these out. So, the first method it involves math. So, you take the two oxidation numbers, put them like that, draw another line right there. So, you take the closest multiple of 1 and 2, which that would be both 2. So for 1, it would be 2, and for 2, it would be 1, to get that number. So it's 1 times 2 is 2, 2 times 1 is 2. So then you can write it out, it's Na2, now the 2 is now at the bottom, and the 2, you can see on this column, is all the Na, and on this side is sulfur. So then I just write S, and that's it. You don't need to put the minus or plus or anything like that. So that is my final answer for sodium sulfide. Now on to boron sulfide. Now boron is right there, and so it's B 3 plus. And sulfide again, it's right there. You do S 2 minus. So now there's another way of doing it. It's a lot faster. It's easier. There's only one time that it can't work, and I'll tell you that after I do this. And it's very easy. All you have to do is just move the numbers across like that with the little arrows. So final answer would be B2S3. So that is my final answer. But the only time this doesn't work is, say we have, I'm just going to put letters on here. So say B had oxidation number of 2 and S had oxidation number of 2. These are not real, so don't go saying, hey, is boron have 2 oxidation number. But if it's 2 plus and 2 minus, then they cancel out. It would just be 1. It would just be B and S. There wouldn't be numbers. So the 2's cancel out. So it helps to double check with this method right here. But that's about it. Okay, on this page we're going to name polyatomic ions. Now I have a few polyatomic ions on this chart right here, or board right here, but it's not all of them. So if you can't find, say, you can't find peroxide, you have to go look it up on Google or something like that. Look for a chart on Google that has all of them. But I only have some of them up on here right here. So again, we're gonna basically kind of do the same thing, but it's a little different. So for potassium, I mean it's the same thing. K right there. So K 1 plus. And then hydroxide. So now we look up on this chart, and hydroxide is right there. It's HO 1 minus, or minus 1. OH 1 minus. So this is the easy one. You just write K And that's the final answer. We didn't have to really do any work on this one since the oxidation numbers are both 1. So now we're going to go move on to a trickier one. So we have ammonium. So ammonium's the only positive polyatomic ion. That's the only one. I mean, all the other ones you can see are negative, 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 and so on. So ammonium is NH4 plus. And then carbonate is CO3 2 minus. So these numbers are already down here. They're going to stay right there. They're not going to move. So the 4 and the 3 are not going to move. So we're going to do the crisscross method here. So it would be NH4, but then the 2 has to go there too. So what you have to do is put them in parentheses like this. And then you put a 2 there on the outside of the parentheses. And then you move on to the next letter if there is a next letter. Most of the time, the parentheses go on the second one, but not in this case. And then it would be CO3. And that's all for this slide. Alright, on this slide we're going to be doing molecules. So I have a little chart right here to understand how many atoms are in each phrase thing. So here we have tetraphosphide. So tetraphosphide, it obviously has 4 atoms. So we have to still look at the symbol for phosphorus. And it's P. So P, and then we just go to 4 right there. 4. So P4. And trioxide is obviously oxygen again, and that would have 3. So this is really easy as long as you can know the prefix right here. So that's our final answer. So diphosphorus is basically the same thing, except di is 2. So 2, and then monoxide is just going to be O. So that's all for this video. I hope you enjoyed. If I did anything wrong, please leave it in the comments, and I'll try to do better in my next video. Thank you.